Next. Alright, this is an interesting one. A man has a velocity, initial velocity of 3 meters per second, start z meters behind a bus with velocity equal to 0, at time equal to 0. Okay, the bus accelerates with an acceleration of 1 meters per second. Does he catch it? Okay, well obviously this is all going to depend on the time and the distance z that he's behind the bus. Okay, so the velocity, the position of the man is equal to x0 plus v0 man plus 1/2 acceleration of the man times t squared. But there's no acceleration, so that's equal to x0 plus v man t. And x bus is equal to x0 plus z. Right? That's the distance between the two, plus v0 bus t plus 1/2 a bus, which we know is 1 t squared. So that's equal to x0 plus z. There's no initial velocity, plus 1/2 a bus t squared. Okay? So basically, if the distance of the man, or if x man is greater than x bus, he's going to catch it. And this occurs at the if that distance z is less than a certain distance. Okay? And that kind of makes sense. So if the bus is way over there, right? You know, there's a certain amount of time that you can get it. Z is going to be related to time. So yeah, there's a certain amount of z and t that you can't get it. Now, that thing may be accelerating really fast, but if I'm right here next to the bus, I can catch it really fast because the distance is not very long. So it's all kind of interrelated. Okay, so basically that's if x man, which we know is x0 plus v man t, is greater than x0 plus z, the bus, plus 1/2 a bus t squared. And we know here, you can eliminate a bunch of different things. You can eliminate your x's and stuff like that. So 3t is greater than z plus 1/2 a bus t squared. Do your algebra, z is less than 3t minus 1/2 times 1t squared. Right, and z is less than 3t minus 1/2 t squared. Okay, so that's what helps you determine what it is, and if he's going to catch the bus or not. So you need to. Okay, moving right along. Okay, so a block of mass m1 is attached by a string to a support. The block is raised to a height h, released, and it strikes a block of mass 2 on a frictionless surface. Find the velocity of m2, assuming totally elastic. So remember, elastic energy, okay? Inelastic, no conservation of energy. Just remember that, okay? But in this case, we've got, system's going to kind of look like this. Remember, I'm no artist. We know that information there. Okay? Alright, so we know the potential energy from up there is going to be converted into kinetic energy. Okay, so 1/2 mv1 squared is equal to m1 gh. So v1 is equal to the square root of 2gh. So that velocity when it hits it is going to be 2gh. So for totally elastic, you're also going to have conservation of momentum. So m1v1 to the m2v2 equal to m1v1 prime plus m2v2 prime. We've already solved this from earlier, knowing our different formulas that we need to know. So v2 prime is equal to v1 times 2m1 all over m1 plus m2, and that is equal to square root of 2gh times 2m1 all over m1 plus m2. You just got to know your potential energy, mgh, kinetic energy, 1/2 mv1 squared. You can use that because it's elastic. Solve for your velocity, you get your velocity there. Now what happens to momentum? Well, it's elastic, so there's going to be two separate, it's going to be broken into two separate momentums here. Okay? and then you can just solve. Okay, and just use those formulas that I gave you earlier. Okay. Good deal. Okay. Next. Yes, everybody's seen these in the office before. You have a pendulum. Okay, and why will only one ball swing out? And basically, this just has to do with conservation of energy and momentum. The energy and momentum of this one, you have energy, right? Potential energy, whatever the height is above the other balls. You show it up here, for instance. That's going to be mgh, okay? That's going to be converted into kinetic energy. But that kinetic energy of this first ball is going to be converted into the energy of this ball, into the energy of this ball, into the energy of this ball, and it's all going to be conserved as long as it's perfect, a perfect system. And so this is going to be the only ball that's going to swing out. So y'all have seen that all before. You just need to know that you're using conservation of momentum and conservation of energy, and each ball is transferring to each other using those conservation laws. Okay? Here's another bullet one. They're very similar.